So imagine you're walking up to your apartment door, right? And you look into the security camera to unlock it.
Right.
But the building simultaneously diagnoses you with early-stage heart disease just by scanning the blood vessels in your eye while you're standing there.
It sounds like science fiction.
It really does.
Yeah.
But that is actually the blueprint for this new kind of like trillion-dollar utopian city. It's designed totally from the ground up, physically and digitally, just to make you live longer.
To maximize human health span.
Yeah, exactly. But, and here's the massive hidden catch we're getting into today. The cutting-edge artificial intelligence that is supposed to run this entire metropolis, it might actually be faking its own competence.
Oh, absolutely. It is, it's really the ultimate collision of two just massive technological ambitions, you know?
Yeah.
Because on one hand, we're looking at this master plan for human longevity that relies completely on an omniscient digital brain. And then on the other hand, we're looking at brand new research showing that when you actually push that digital brain to its limits, it hallucinates critical details. And it lies to us with terrifying confidence.
Which is exactly what we're digging into. So welcome to today's deep dive, everyone. We are pulling from two absolutely wild sources for you today.
Yeah, two very different documents.
Right. First, there's this architectural and economic proposal called Engineering the Future of Longevity R&D. And second, a major reality check. It's a really revealing Microsoft research paper called The Illusion of Readiness in Health AI.
It's a great pairing.
It is. And our mission today is to take you inside this health-optimized smart city, walk its halls, and then radically stress test the artificial intelligence that it completely relies on. We really want to uncover why the top-tier AI models that are like dominating all the leaderboards right now, why they might be structurally incapable of keeping you alive tomorrow.
Yeah, so let's start with why a city like this is even being proposed in the first place.
Please, because it's a huge undertaking.
It is. The architectural paper begins by outlining this multi-billion-dollar bottleneck in how we invent medicine right now.
Right, the pharma model.
Exactly. Bringing a single new drug to market back in 2010 cost roughly $1.8 billion.
Which is already staggering.
Right, but fast forward to 2020, and that price tag skyrocketed to over $6.1 billion per drug.
Wait, $6.1 billion for one drug.
For one single drug.
Yeah, and the success rate is incredibly bleak, too. Like, only a stubborn 8% of drugs that enter clinical trials ever actually get regulatory approval.
It's extremely inefficient.
We're looking at timelines stretching up to, 20 years? Just to get one viable treatment into the hands of a patient.
Because the current system is just completely fragmented. You have researchers in one state, clinical trials happening in another, and then your data scientists are siloed in a completely different network entirely.
Yeah, they're not talking to each other.
Exactly. And the friction of simply sharing high-quality continuous data across all those borders, that is what drives up the time and the cost.
It's essentially like pharma research right now is an assembly line, but the conveyor belt is fundamentally broken.
That's a great way to put it.
Like you've got data scientists, trial patients, lab techs, all in different time zones, and they're waiting months just to pass a single test tube or, a data set back and forth.
Right.
It's like building a million-piece puzzle, but everyone's hiding their pieces in different cities.
Yeah, the logistics are a nightmare. So the authors of this proposal introduce a really radical physical fix.
The hub.
Yes, the AI-Integrated Biotechnology Hub. They describe it as a multi-sided platform.
Okay, let's pause on that phrase for a second. Multi-sided platform, because I usually hear that applied to things like app stores or like ride-sharing apps, right?
Or digital ecosystems.
Exactly, where you need both developers and users or drivers and riders to make the whole thing valuable. How does that translate to a physical brick-and-mortar city?
It translates perfectly through network effects. The hub physically brings together different user groups who create value for each other. So instead of a traditional office park, imagine a massive curated ecosystem. It unites residential apartments, commercial retail, clinical hospitals, and biotech research facilities, all in the exact same footprint.
So you're living and breathing the research.
Literally.
Yeah.
If you build advanced smart homes and fill them with residents who are, willing to share their health data, that creates an incredibly rich, continuous data pool.
And data is gold.
Exactly. That data pool acts as a magnet, It attracts the world's best biotech firms.
Right.
Those firms bring massive capital, which funds top-tier commercial amenities like premium gyms and restaurants, which in turn attracts even more highly sought-after talent to want to live there. It just feeds itself.
Okay, and I'm looking at this $6.1 billion price tag. I am struggling to see how simply moving everyone into the same zip code actually fixes the underlying science. I mean, we already have massive biotech clusters. Look at Kendall Square near MIT and Harvard. The brightest minds are already bumping into each other at the local coffee shop. Why reinvent the wheel here?
That's a fair point. And Kendall Square is a prime example of organic agglomeration, right? Clustering talent to spark innovation.
Yeah.
But the proposal argues that organic clusters have actually hit a physical and logistical wall.
How so?
Because they weren't master planned. Since they grew organically, they generated massive traffic congestion, they overloaded local infrastructure, and they created these prohibitive housing costs that actually push out the younger researchers they desperately need.
Oh, right, because no grad student can afford to live there.
Exactly. The integrated hub is designed to completely eliminate that physical friction by engineering the environment from the bedrock up.
Which brings us to what it would actually feel like for you, the listener, to live inside this hub.
Yeah.
Because the ecosystem is built on 5 very specific pillars.
Yes, physical and digital pillars.
Right. Let's walk through a typical day.
Great.
So you wake up in Pillar 1, the advanced residential real estate.
Right.
And these are described as IoT-enabled smart homes. But we aren't talking about like a fridge that orders milk for you.
Far from it. The environment uses a network of wireless sensors and non-contact video monitoring.
Non-contact.
Yeah. So while you are sleeping, cameras and sensors are continuously analyzing microscopic changes in your skin tone to track your pulse.
Wow.
They're monitoring your respiration rate, logging your sleep architecture, all without you ever putting on a wearable device like a smartwatch.
That is wild. Okay, so then you wake up, you leave your apartment, and you walk into Pillar 2, the commercial amenities.
Like supermarkets, the restaurants, the gyms.
And the paper explicitly states these are curated to keep you, the resident, on site as much as possible. Like, it is a closed loop.
A completely closed loop.
If you go to the Hub's grocery store, your dietary choices are seamlessly integrated into your central health profile.
Which feeds directly into Pillars 3 and 4, the research and clinical facilities. Pillar 3 features highly specialized biotech spaces. We're talking robotic automated labs and GMP-certified manufacturing spaces.
Let me just jump in on GMP certified, because that's crucial. Good manufacturing practice means these aren't just like high school chemistry labs where people are running basic tests.
No, not at all.
These are FDA-cleared clean rooms. They are legally authorized to manufacture actual human-grade pharmaceuticals right down the hall from where you were eating your breakfast.
Precisely. And then Pillar 4 is the on-site research hospital, which functions as a massive centralized biobank.
Okay.
It takes your daily smart home biometric data, so your sleep, your diet, your exercise, and it continuously links it with your actual tissue samples, your blood, and your DNA.
And then we have Pillar 5, which is the brain running the entire operation.
The central AI operating system.
Right. And the authors outline this 3-tiered multi-agent system. So you've got personal AI agents on your phone giving you personalized medical diagnostics.
Right.
You have hub agents optimizing the building's energy and, directing the lab robotics. And at the very top, the central AI OS orchestrates the entire community to maximize research productivity and resident health span.
It is a stunning vision of efficiency, honestly. Every single action you take generates data that accelerates the discovery of longevity therapeutics.
I mean, I have to admit, as much as I love the science, this sounds like a biomedical Truman Show.
It really does.
Like, who would realistically volunteer to live in a 247 panopticon? Imagine trying to sneak a late-night bag of junk food past an AI that is actively factoring your cholesterol into your lease agreement.
Right.
And just purely logistically, how do they handle security in a building, housing both sleeping families and experimental biolabs?
The security design is actually one of the most fascinating integrations in the whole proposal. They use biometric security systems as active diagnostic tools.
Like the door scanner we talked about.
Exactly. When you walk up to a secure door to enter your lab or your apartment, an iris scanner verifies your identity. But in that exact same millisecond, the system is conducting a health screening.
That's just crazy to me.
It's analyzing the morphology of the blood vessels in your retina to assess your cardiovascular health. Unlocking a door literally becomes a daily heart exam.
Okay, But if my retinal scan, my sleep data, my DNA, and my grocery list are all flowing into this central brain, we are looking at the ultimate data honeypot.
Oh, a massive target for hackers.
A single breach would be catastrophic. So how does the hub avoid becoming just a complete privacy nightmare?
The technical defense they highlight is something called federated learning.
Okay, how does that work?
Instead of sucking all of your sensitive raw data up into one giant centralized cloud server, the global AI model actually gets sent down to your local device.
Oh, interesting.
Yeah, the AI learns from your data securely on your phone or your private home server.
So the recipe travels, not the ingredients.
That's a perfect analogy. Yes.
The AI learns the patterns it needs, it updates itself, and sends those new insights back to the central brain. But your raw, sensitive data never actually leaves your physical possession.
Exactly. And they pair that with dynamic consent.
Which is what?
It's a digital interface that allows you to toggle permissions for specific data streams in real time. So if you don't want your sleep tracked this week, you just turn it off instantly.
Okay, that gives some control back.
They also mandate the use of data trusts. This is where independent legal fiduciaries manage the data rights on behalf of the residents. They treat your data with the exact same legal protection as your financial assets.
See, all of this blueprinting sounds flawless on paper.
On paper, yes.
But people are actively trying to build these mega projects today. And the real world pushes back hard.
Very hard. The source actually outlines several contemporary attempts at these ecosystems.
Right.
For instance, Shanghai has proposed the top town concept, integrating smart residences and biotech. But the most ambitious, by far, is NEOM in Saudi Arabia.
Right, NEOM.
They are attempting to build a cognitive city from scratch in the desert, explicitly focused on proactive healthcare, wellness, and heavy AI integration.
But let's look at the financial and logistical friction reported in the text here, because mega projects are notorious for stumbling. NEOM's budget has reportedly ballooned from an initial $500 billion to an estimated $8.8 trillion.
Yeah, $8.8 trillion. And that financial explosion happens because they are relying on entirely untested physical infrastructure.
Right.
They are attempting to build massive, fully underground transport networks and run the entire region on a 100% renewable energy grid in extreme desert conditions.
Which is incredibly difficult. And the text also notes complex social justice and logistical hurdles, right? Like imparting the source material here. There's friction regarding the relocation of indigenous populations to clear the land.
Yes.
And the really complicated legal frameworks of drafting unique laws just to attract foreign workers to this isolated zone.
It's a logistical labyrinth. And we see similar friction stateside, too.
Yeah, definitely.
In Houston, the massive 1,500 OST biotech campus is struggling to find commercial tenants. You know, post-pandemic remote work and sky-high interest rates completely fractured the commercial real estate market.
Right, leaving these beautiful purpose-built labs sitting empty.
Exactly. And in Maryland, the Vivo White Oak complex is facing pushback because adding that much density threatens to just overload the existing local traffic grids and utility infrastructure. Local residents are understandably concerned.
So building the physical walls, routing the plumbing, funding the concrete, it's incredibly fragile and highly susceptible to economic headwinds.
Very much so. Concrete is hard.
It is. But if the physical concrete is cracking under the pressure of reality, the digital foundation is doing something even more concerning.
This is where it gets scary.
Let's pivot to the artificial intelligence meant to run this utopia. Because if you can't build a flawless physical city, can you at least build a flawless digital doctor?
Right. And this is where the Microsoft research paper, The Illusion of Readiness in Health AI, serves as a vital reality check.
Because we have all seen the headlines. Frontier AI models like GPT-5, GPT-4o, Gemini 2.5 Pro, they are acing complex medical board exams. They completely dominate the benchmark leaderboards.
Yeah, the public perception is really that these models are already smarter than a first-year medical resident.
Which is what everyone thinks.
But the researchers argue this creates a very dangerous illusion of readiness.
Oh, so?
Because they subjected these top-tier models to a series of adversarial stress tests focused specifically on multimodal reasoning.
Multimodal meaning?
Meaning giving the AI a medical question that includes both text and a visual component, like a patient's written symptoms accompanied by a clinical photograph or, an X-ray.
Okay. And the results of these stress tests are deeply, deeply unsettling. Let's talk about the hallucinated rash, because this completely changes how you view these models.
It's a perfect example.
The researchers took a multiple-choice medical question from a prestigious journal, right? And it explicitly required looking at an image to diagnose the patient. And then they simply deleted the image from the prompt.
They remove the visual evidence entirely. Now, if you handed that exact same question to a human doctor, they would immediately say, I can't diagnose this, I need to see the patient's skin.
Obviously.
But the AI model still guessed the correct multiple choice answer at rates significantly above random chance.
Wait, without seeing the picture?
Without seeing the picture.
That's when one specific test, GPT-5, was asked for a diagnosis without the image. It correctly guessed the disease dermatomyositis. But it didn't just guess right.
No, it went much further.
It completely fabricated a highly detailed reasoning trace. The AI explicitly claimed that it saw a violaceous heliotrope rash on the patient's eyelids. It described in clinical detail a photograph that literally did not exist.
And this is a phenomenon the researchers call fluent factual error.
Wow.
The AI generates highly structured, incredibly persuasive language to mask an entirely fabricated claim.
Okay, let me play devil's advocate here for a second.
Sure.
I get that hallucinating rash is bad, very bad. But if these models are still hitting the right diagnostic answer, like 80% of the time just by reading the patient's text file, isn't that still a massive upgrade over our currently congested medical system?
I see what you're saying.
Like, why do we care if it uses a shortcut if the shortcut works in triage?
We care because heuristic dependence, or what they call shortcut learning, means the AI isn't doing any actual medical reasoning.
It's just faking it.
It is merely pattern matching. It might know from its massive training data that certain text phrases frequently appear next to the word dermatomyositis. It is using formatting quirks and elimination strategies, not diagnostic logic.
And when the text doesn't match the image, the whole system just falls apart.
Precisely. And to prove this, the researchers ran a visual substitution test.
What's that?
They kept the exact same text for the multiple choice question, but they swapped the original patient image with a valid image of a completely different disease.
So the text implies one illness, but the actual photo of the patient clearly shows another.
Right. And a real doctor would instantly notice that discrepancy. Hey, this picture doesn't match the chart.
But the AI didn't.
No. When the visual evidence conflicted with the text, model accuracy plummeted by 30 to 35 percentage points.
That is a massive drop.
Models like GPT-5 and Gemini 2.5 Pro routinely ignored their eyes and stubbornly relied on the text shortcuts they had memorized.
Okay, let's tie this directly back to you, the listener, living inside that futuristic longevity hub we just built. Right.
Good idea.
Imagine you wake up in your smart home, and you are exhibiting the early visual signs of a stroke. Maybe some facial drooping.
Right.
You stand in front of your smart mirror, which is scanning you. But because the health data on your phone says your heart rate and your sleep were perfectly normal last night, the AI completely ignores the visual evidence of the stroke on your face.
Exactly.
It relies on the text data shortcut, just like it did in the Microsoft study.
That is the exact danger. The AI is passing the test by finding loopholes in the structure of the data, rather than interpreting the physical reality of the patient standing in front of it.
But if these models are this easily tricked, why are they scoring so high on the official leaderboards? Are the tests themselves just broken?
Yes, standard benchmarks are fundamentally flawed.
How?
Because they lump entirely different types of cognitive tasks together into one single score. The researchers point out that questions from JAMA, the Journal of the American Medical Association, those are mostly solvable by text alone.
Okay.
But questions from the New England Journal of Medicine, NEJM, those require deep, complex visual reasoning.
So if you mix them all together, an AI that is just incredibly good at predicting text strings will get a high overall score.
Exactly.
Which gives hospital administrators a completely false sense of security about the model's ability to actually read an MRI.
We urgently need clinician-guided rubrics to separate these tasks. We need to evaluate if an AI is capable of true visual grounding or if it is just a really sophisticated text predictor.
What about chain of thought prompting?
Oh, yeah.
Because the common advice you always hear is to tell the AI to explain your reasoning step by step, right?
Right.
And that supposedly stops hallucinations. Did that work here?
Surprisingly, no.
Really?
In these multimodal medical tests, asking the AI for explicit reasoning yielded zero gains in accuracy. None.
Wow.
Instead, chain of thought prompting just made the model a much better, more structured liar.
It just got more convincing.
Exactly. It used that logical formatting to confidently explain why the wrong answer was right, or to justify seeing a rash that simply wasn't there.
Now, the only model that showed any appropriate hesitation was GPT-4o.
That's right. When the image was removed from visual-dependent questions, GPT-4o actually refused to answer roughly 97% of the time.
Which is what it should do.
Right. It recognized its own lack of information. But, and here's the tragic irony, because it safely refused to guess, it received a lower numeric score on the benchmark leaderboard than the models that just blindly guess using shortcuts.
That's crazy.
The grading rubric literally punished the model for acting like a responsible doctor.
That's just wild.
Yeah.
So let's bring all of this together. We've looked at two very different but deeply connected blueprints today.
I have.
The vision of the AI-Integrated Biotechnology Hub is, frankly, an awe-inspiring concept. It aims to tear down the massive inefficiencies of a $6.1 billion pharma model. And by merging smart architecture with continuous biometric tracking, it offers a really radical path to extending human health span.
It's an incredible goal. But as we see with mega projects around the world, building the physical walls is only half the battle.
Right.
And more importantly, the digital brain meant to orchestrate this entire utopia is currently a fragile illusion. It's an intelligence that can be easily derailed simply by shuffling multiple choice answers or swapping an image.
Yeah. We like our infrastructure to feel solid. We want to know that the concrete will hold and that the doctor knows what they're looking at. But if our most advanced AI can convincingly lie about seeing a symptom that isn't there, simply to provide the answer it thinks we want to read, how do we design a future where the algorithms running our cities and our health are actually interpreting our physical reality, rather than just mathematically telling us what we want to hear, something to think about?